Right. So, good morning, everyone. I welcome you all to this day one session of the bridge course. Right. So, let me explain you what we are going to discuss today. So, the idea is to understand the basic functional components of a computer. Right. So, let me explain you the fundamental things. So please observe this diagram carefully. This is the block diagram of a computer, and I want everyone to observe this diagram carefully. Right? Every one of us are aware of a computer. Everyone may be knowing what is a computer, but if you look into any textbook or maybe in internet, the diagrams which you see for block diagram of a computer, you will be seeing different types of diagrams, right? Wherein all IO devices are also connected to CPU directly, which is wrong, my dear friends. So please observe here, this CPU is called as central processing unit or the processor. And if you observe this, CPU has a direct connection with only one device, and it is called as main memory. This main memory is also called as primary memory, and this main memory is also called as RAM by many people. RAM, maybe you are aware of this word RAM, right? Actually, this RAM should be called as DRAM, dynamic random access memory, right? So observe this diagram carefully. CPU always interacts with main memory directly. We will be using this concept in our entire programming journey down the line, even after you join the college, and once you start learning programming. In programming also, this diagram is very important, my dear friends. So CPU always interacts with only one device directly, that is called as main memory, right? And all other devices, it can be your hard disk, it can be your monitor, it can be your keyboard, all input output devices. If you observe, see here, IO device 1 dot IO device n number of devices can be connected to a computer, but they are not directly connected to CPU. This is a fundamental point to be noted. And this horizontal line which you are seeing, the very big horizontal line which connects these IO devices to the CPU, this horizontal line is called as external bus, right? This horizontal line, let me connect it properly. Fine. So friends, this horizontal line, this horizontal line, this horizontal line is called as external bus. So if you observe this diagram carefully, if any IO device, input output device, wants to send some data to CPU, there is no direct connection. This IO device has to use this external bus, and via this external bus it will go to main memory, and from main memory, so external bus, and from external bus it will, via external bus it will go to main memory, and from main memory it will go to CPU. Similarly, if CPU has to send something to any IO device, it will send it to main memory, and from main memory it will come to external bus, and from this external bus, which is a common bus connecting all IO devices, from this external bus the data will reach to appropriate IO device. So the most fundamental point in this diagram is CPU will never talk to any IO device directly. The only device with which CPU interacts directly is called as main memory. Right, friends? So main memory is a place where you can store data, or where data and programs are actually stored, and CPU can access them to process the data and programs, right? Till this point, if you have any doubts, please let me know. I'm waiting for questions in the chat box. You can ask your questions in the chat box. I'm waiting for questions. Do you have any questions till this point? Shall we move on? Shall we move on? Okay. No doubts. If you let me know in the chat box, if you have any doubt, you can type, or else you let me know whether, sir, you did not told basic thing, who invented a computer. See, who invented computer? See, I'll tell you. Let me share my screen again. So friends, the diagram which you are seeing is the diagram of an electronic computer, right? The diagram of electronic computer. Before this, some 60, 70 years back, first time when a computer was developed, I hope you might have heard the name Charles Babbage. Charles Babbage is the name of the person who developed the computer, right? So computer is developed, it's not invented. So as Charles Babbage. And Charles Babbage has developed a computer which is called as first computer, but it was a mechanical device. It was not pure electronic device, right? So this pure electronic since Charles Babbage machine was not a pure electronic device, it was not that comfortable for us to use, right? Now what happened is, I hope you may remember, or you might have seen in your childhood, that we used to have something called as floor mills, right? Floor mills. These days we have grinders, very big grinders and mixers at our house, but still there are some floor mills available in the market, right? Suppose if I have 10 kgs of wheat to be converted into flour, I used to go to a shop called as flour mill. I hope you might have seen, right? Now, if you recollect that flour mill, how flour mill operates, there used to be one end from where you insert the wheat. There was one opening, one box wherein you put it, that shop fellow will put some wheat into it. Suppose I have taken 10 kgs of wheat, all 10 kgs can't be inserted into that box. So 2 or 3 kgs he'll put into that box. Then he will turn on the machine, and that machine will work, or it will crunch that particular wheat into flour. And that flour, if you remember, will be collected in an another box at the outlet. So why I am giving you this example is, try to recollect the flour mill. In that flour mill, we were supplying the inputs externally and we were collecting the output externally. Similar to that flour mill, Charles Babbage computer was also operating, wherein we used to give inputs externally and we have to collect outputs externally and manually. This was very, very, very tough. That's the reason, friends, the Charles Babbage machine, even though he is called as father of computers, right? His computer, I'm sorry, his computer was a mechanical device, and that's the reason it was not that successful. And after a decade or so, John von Neumann is a mathematician. Basically, John von Neumann is the one who developed the first electronic computer, right? First electronic computer which contains main memory. So friends, prior to that, there was no main memory, and John von Neumann's machine contains the main memory, and that is the first electronic computer. So what is the difference between electronic computer and the previous one is, it contains main memory, and this computer was developed by John von Neumann with a concept called as stored program concept. The meaning of stored program concept is, any program or data which has to be processed should be made available to CPU in advance by keeping it in a place called as main memory. So previously we were supplying inputs externally and manually. Instead of that, we store our data, we store our instructions in a place, and CPU will access the data and instructions from that place, and it will process the data, it will process those instructions, and it will return the results back, or it will write the results back to the same place called as main memory. So friends, this electronic computer is the one which we are using even today, and that's the reason John von Neumann is called as father of electronic computer, right? So did I answer your question, Nikhilesh? Yeah. See, this is a very good habit that you are asking questions, and please continue this till your 4 years of engineering, because if you don't ask questions, nobody is going to explain you things elaboratedly, right? So let us go back and continue. Now, why CPU? I was telling you since beginning, like CPU does not interact with main memory directly. Sorry, it will interact only with main memory directly. It will not interact with any other IO device directly. So there should be a reason why, right? So the reason is very, very simple, friends. Suppose, suppose I am teaching you a class. First time we are interacting in an online mode. Now let us assume I can teach 100 points in 1 hour. Let us assume I can teach 100 points in an hour. But your capacity is you can only understand, or you can only listen, you can only grasp 10 points per hour. So what is your capacity? 10 points per hour. What is my capability? I can teach 100 points per hour. Got the point? Now what will happen, friends, if we operate at our own speeds? Means every day I'll come to your class, I'll be teaching 100 points per hour because I can teach 100 points per hour. Whereas you can only understand 10 points per hour. Then what will happen if we both communicate every day at our own speeds? Do you think that communication will be useful? Do you think that communication will be useful? Please respond in the chat box. Right. So that it's of no use. Like I'll be teaching 100 points. I don't know which 10 points a student has understood. One student might have understood first 10, another student might have understood next 10, but nobody will understand my class completely. Then what can be done? I have two options. Right. I'll come to your class and I'll say nothing doing. Tomorrow onwards, you should start understanding 100 points per hour. Is it possible? Is it possible all of the sudden I'll come to you and I'll say, no, no, tomorrow onwards your capability should increase 10 times, right? 10 points per hour, you can understand. I don't know, tomorrow onwards you should understand 100 points per hour. All of the sudden, I can't expect you to increase your understanding ability that to 10 times. So first option is not possible. What is the other option, sir? What is the other option? What is the other option? I'm very happy that people are responding. So what is the other option? Your speed can't be increased or your capability can't be increased. So what can be done? Tell me what is the other possible option. There is one more option. That's great, Ramcharan. That's great. The other option is very simple. Instead of me teaching 100 points per hour, I should start teaching only 10 points per hour. Now tell me, if I can teach 100 points per hour, but I am teaching only 10 points per hour, then what is my efficiency? Am I operating at my full strength? Am I operating at my full capacity? What is the percentage of my efficiency? Yeah, obviously I'm not operating at my full capability. I can teach 100 points per hour, but I am teaching only 10 points per hour. Then what is the percentage of my efficiency? What is the percentage of my efficiency? Only 10 points I am teaching, wherein I can teach 100, right? Excellent. So my operating efficiency is only 10%. Now coming back to this diagram, exactly the same thing will happen here, sir, because CPU is a pure electronic device present in any digital computer, whereas our other input output devices like printer is there, monitor is there, keyboard is there, right? They are all not pure electronic devices. Some are electrical devices, some are mechanical devices, some are electromechanical devices. So what will happen is, since CPU is a pure electronic device and CPU operates at a very high speed, friends. Now what will happen is, if CPU start interacting with all these IO devices, its performance will affect, because all these IO devices are very slow when compared to CPU. This is very much same as the example which we have discussed just now, 100 points per hour and 10 points per hour. So CPU, if it starts interacting with IO devices directly, it will affect the performance of the CPU, right? Why we use computer? Because it is very fast in computing than us. That's the reason we want to use computer. So but if I ask computer to operate at an efficiency level of 10%, then there is no meaning in using a CPU, right? And you can't say, see, I am using a i3 processor, I bought a modern processor faster than i3, I bought i5, and someone says, no, no, mine is i7, which is much faster than i5. Then what is the difference if you use i3, i5 or i7 when your CPU is operating at the speed of IO device? It doesn't make any difference, no? Like, one faculty can teach 100 points per hour, another faculty can teach 200 points per hour, third faculty can teach 300 points per hour. It doesn't make any difference when all of these three faculties are teaching 10 points per hour. Same is the case here. If CPU starts interacting with these IO devices, its efficiency and performance will not be good. It is very less. That's the reason CPU will never interact with these devices directly. Now the only device with which CPU can interact directly is main memory. Now the point is the main memory so fast? Right? So main memory is not that fast, sir. It is not exactly same as the CPU speed, but it is far better than all other IO devices. It is far better, right? It is not exactly same as our CPU, but it is far better than all other IO devices. That's the reason CPU will access only main memory directly. Now, what is the purpose of main memory? Main memory will not do anything, sir. It's a place where you can store data and programs. Main memory is a place where data and programs are stored. CPU is the only device in the computer which will be doing the processing task, right? So who is the worker inside the computer? Only worker inside the computer is a CPU, central processing unit. Means any executing a program, processing some data, anything related to execution, it is done by only one person, one device called as CPU. CPU is also called as processor. So only worker inside the computer is CPU. And what is main memory? It's a place where your data and programs are stored or created. And who will interact directly with main memory? CPU. The only device with which CPU interacts directly is main memory. All other IO devices communicate with CPU via main memory using external bus. So this is what we say, a brief explanation of block diagram of a electronic computer or a digital computer. So till this point, what is CPU? It's a central processing unit. I'm summarizing what we have discussed. CPU is stands for central processing unit. Its job is to execute your programs. Its job is to process the data. It is the only worker present inside the computer who can do something for you, right? So entire processing load is handled by CPU. Main memory, it will not do any processing, sir. Main memory will only store data and programs which can be accessed by CPU. And CPU will write the results of your program again back to main memory only. So main memory is not involved in any execution part. Main memory can't process anything. Main memory is only a storage device or a place where data and programs are actually stored or created. Fine. So till this point, are the things clear to you? If you have any doubts, you can please type in the chat box. Obviously, okay. So that's great. So we will move on, right? We'll move on, right? So computer contains two things. One is hardware and software. Now, before we actually move on to this slide and before we actually continue, let me explain you a few things. Let me explain you a few things. Fine. Now, I have a question for you. I have a question for you. The question is, listen to the question carefully, right? The question is, probably anybody can answer this question, right? Where is the chat box? Yeah. The question is for everyone. You need not type the answer, but probably, you try to give the answer to yourself. I'll be asking questions, right? 3 into 4. 3 fours are 12, right? 5 fours are 20. 6 sevens are 8 twos are 9 threes are 10 fives are 1526 into 1499. 1526 into 1499. Friends, I was asking you some small multiplications kind of thing. And what is the difference between all those previous questions and 1526 into 1499? For all those previous questions, you were able to give the answer immediately, yes or no? For all other questions, like when I say 5 fours are 20, immediately you can give answer. I can also give answer immediately. But the moment I say 1526 into 1499, not only for you, for me also, it will be difficult. Immediately, I can't give answer. Yes or no? Immediately, I can't give the answer. And there is a chance that I may commit a mistake also. At the end of the day, we are human beings. So if I say, give me the answer for 1526 into 9974. Immediate answer can't be given. But there is a chance of giving a wrong answer also. Even though when we do calculations, there is a chance that we may give wrong answer. Yes or no? Do you agree with me? Yeah. So friends, what will happen is if we write a program, if you write a program to multiply two numbers, okay, and when you run that program, when you give inputs to computer, whether you give 5 into 4 or 3 into 4 or 3 into 9 or a 1526 into 1499, irrespective of the size of the number, irrespective of how big the number is, you will get the answer immediately. You will get the answer immediately. And once you write the logic for multiplying two numbers, computer will not commit any mistake. So if you say 1526 into 1499, it will give you the answer immediately. And of course, it will be correct. So what is the difference between human and computer? The very important point to be noted is human and computer. As far as computing is concerned, computers are faster than us. And accuracy, if I ask you 10 different numbers of 3 digits or 4 digits, always there is a chance that at least 1 or 2 times you may give wrong answer, yes or no. So the difference between humans and computers is computers are fast and accurate than us. So do you agree with me? Of course, calculator itself is faster than us, right? So obviously computer will be much faster than us. So computers are fast and accurate than us. Then that's the reason, since computers are fast and accurate than us, I want to use the computer for solving my problems, for executing my jobs. Now the point is, how do I use the computer? Now the point is, how do I use computer? I know that computers are fast and accurate. That's okay. But how to use computer? I asked the questions to you like, tell me what is 3 into 4, tell me what is 5 into 4, give me the product of 1526 into 1499. I can ask you like this. You understand what I was asking. But I can't ask this kind of question to computer in English. I can't say, hey, computer, give me product of 1526 into 1499. I should convert it into an instruction which computer can understand, right? So friends, based on this question, we land into an important discussion here. Right? So, can I give instruction to computer using my own language? Can I give instruction to computer using my own language? I'll be using this, yeah. Computers are fast and accurate than us. There is no doubt in that. Hence, we want to use computers for our computing needs. How to give instructions to computer? This is an important point, friends, right? I don't mind spending entire today's class in explaining this concept, but one should make sure that they understand this concept, how to give instructions to computer, right? We cannot give instruction to computers using simple English. Means the way I was asking you, right? What is 5 into 4? What is 3 into 4? Like that, I can't give instructions to computer. That's not possible. Then how do I give instruction to computer? How do I give instruction to computer? So first of all, let us understand what is a computer. You have just now seen computer is a electronic device. What do you mean by this? Computer is an electronic device, right? What computer can understand is, since it's an electronic device, it can only recognize, right, presence or absence of voltage, right? Just like fans, sir, you turn on the fan, right? You turn on the switch, the fan will start running, right? Start working, right? If you turn off the switch, it will stop. So it's an electronic device. Computer is an electronic device. So what it can recognize is, it can only recognize two things: presence of voltage and absence of voltage. So presence of voltage is treated as 1 and absence is 0. Hence, the commands given to computer will be in the form of ones and zeros. Example 110001. This is one command. I don't know what is the meaning of this command, but a command will look like this. A command will look like this. Now, for example, I want to multiply 1499 and 1526. I want to multiply. So, what should I do? This is the question. So, what should I do? Now, in order to take the help of computer to solve my problem, I should give command to the computer or instruction to the computer. So how that instruction will look like? The instruction will look like this, sir. I should convert 1499 into binary form. Binary means by means 2. Binary means only ones and zeros. So I should convert 1499 into ones and zeros form and 1526 also into binary form. And I should know the binary form of multiplication instruction. So friends, listen to me carefully. Means for multiplication, what is the command I want to give? Multiply. So for multiplication, there will be a command, and that command will be in binary form. Let us assume this is the meaning of this is multiplication commands binary form. So I should remember this. What is this? This is multiplication. So for addition, there will be a command. For subtraction, there will be a command. And for division, there will be a command. Like that, for everything, there will be a binary command. Then how many such binary commands I should remember? If the computer can execute 10,000 instructions, 10,000 such binary commands I should remember, which is very, very, very difficult for us. So friends, for example, this is the binary code of multiplication. And let us assume this is binary code of my first number. Sorry, 8. It's not 8. It's all ones and zeros. Let us assume that is the binary code of my first number. And this is binary code of my second number. So if I want to tell computer that please multiply 1499 and 1526, I should remember what is the binary code for multiplication. I should know what is the binary form of 1499, and I should know the binary form of 1526. You understood the point. Now, is it difficult or is it easy for me to give command to computer using this binary codes? So the question here is it easy for us to give commands in binary form? So friends, this is the question. So is it easy for us to give commands in the binary form to the computer? Is it easy? I'll be happy to hear from you. Is it easy? Yeah. Difficult. That's great. So friends, this is very difficult for us to manually give commands in the binary form. That is the reason. So this language the language of ones and zeros is called binary language. The language of ones and zeros is called as binary language. It is also called as machine language because machine understands it, right? It is also called as machine language because machine understands it. It's the language of machine because machine understands it. So binary language is also called as machine language, my dear friends. So it is very difficult for me to give commands to the computer in the machine language. So what we will do, we will take the help of something called as programming languages. So I'm slowly introducing few important terminology, few important definitions. So please try to understand. Language of ones and zeros is called as binary language, also called as machine language. Now, what is the definition of instruction? Instruction means command given to computer is called instruction, friends. What is instruction? Command given to computer is called as instruction. Program, set of instructions is called as program. Software, set of programs is called as software. Set of programs is called as software. These three words are clear, friends. What is an instruction? What is a computer? Sorry, instruction, what is a program, and what is a software? Command given to computer is called as instruction. Set of instructions is called as program. Set of programs is called as software. Is it clear, friends? Yeah, we will discuss binary form in detail. That is the next part. Now, friends, so what will happen is I can't give commands to computer in the binary form because computer understands only ones and zeros, language of ones and zeros, which is called as machine language or binary language. Why it understands only binary language means because it's an electronic device. No, what it can understand, it can only see presence of voltage and absence of voltage, which we will convert it into ones and zeros, and we try to give instructions to it. So what computer will understand is only ones and zeros. Now what will happen is, let me elaborate little bit to explain you more clearly what is this machine language. Right? Listen to me carefully. Every processor, nothing but CPU, right? Example i3, i5, i7. These are the examples. No, in your laptop you will have this kind of processor. Every processor comes with instruction set. What is instruction set? Instruction set is set of binary instructions which a processor or CPU can execute. So friends, what is an instruction set? Set of binary instructions which a CPU can execute. Now, for example, I am using an i3 processor. In i3 processor, let us say there are 50,000 binary instructions. It means that i3 processor can execute only those 50,000 binary instructions. That's it. Suppose if i5 processor comes with 60,000 instructions, it means i5 can only execute those 60,000 instructions. So that set of binary instructions is called as instruction set. Now, data will be represented in binary form. Instruction will also be represented in binary form. Instructions come with the processor. Data will be converted into binary form. How the data gets converted into binary form, I will try to explain you, right? But everything is in the form of binary only. Everything is in the form of ones and zeros. But we can't give instructions to computer in ones and zeros or machine language. So we have to think of some other alternative method, which we will discuss shortly. But first of all, let me tell you two things. One is instruction. Every CPU will contain instructions which we call it as instruction set. So for example, in i3 processor, let us assume Let us assume this is instruction for, this is binary code for multiplication. And in i5 processor, same instruction will not be there for multiplication. There is no such rule like in every processor, instruction for multiplication should be same. It can vary also. So I don't know. Now, like this, if there are 50,000 instructions in i3 processor, can I remember 50,000 binary codes? I can't remember 50,000 binary codes. So what will be done? What is the solution that we will discuss? Before that, let me explain you how to convert data into binary form, right? So let us understand this. First of all, there is an important word called as bit. Friends, bit stands for binary digit. What is the meaning of bit? Bit stands for binary digit. Means it can be either 1 or 0. Any one digit, 1 or 0. Then nibble. Nibble means 4 bits. Then byte. Byte means 8 bits. Okay. Then comes kilo. Kilo. K. Kilo means 2 power 10. I'll write like this. Please understand it is 2 power 10. 2 power 10, which is nothing but its value is equal to 1024. So 1 kilo means 1024. The next level is mega. Mega means how much? Mega is how much? It is 2 power 20. Mega means 2 power 20, which is nothing but 1024 into 1024. Then comes kilo, mega, giga. These words you might have heard, no? Giga, 4 GB RAM, 8 GB RAM. So that G means giga, M means mega, K means kilo. So what is giga? How much is giga? 2 power 30. 2 power 30 means how much? 1024 into 1024 into 1024. So what is 1024? It is nothing but 2 power 10. So 2 power 20 means 2 power 10 into 2 power 10. That's the reason 1024 into 1024. Giga means 2 power 30, means 2 power 10 into 2 power 10 into 2 power 10. That's the reason the value is 1024 into 1024 into 1024. Then comes gigabyte, megabyte, kilo, mega, giga. Then comes tera. Tera means 2 power 40, which is nothing but 1024 into 1024 into 1024. One more time, right? 40. Like this and so on. It continues, my dear friends. Right? Now let us try to understand how to measure the data. When we talk about size, we talk in terms of gigabits, gigabytes, like that. So let us try to understand this one. Right? I'll take one example. Note, an important note for you. Small b represents bits, bit, and capital B represent byte. I hope you know the relationship between bit and byte. Byte means 8 bits. Byte means 8 bits. Now tell me, how much is 8 GB? How many bytes it is? How many bytes it is? 8 GB is equal to how many bytes? 8 GB is how many bytes? Only one. 8 GB is how many bytes? You should make a habit of maintaining one standard notebook in the class. Write some important points during our discussion. And this kind of questions will come, so you need some paper and pen to solve them. Okay, how much is 8 GB? 8 bits, 8,000, 8 lakh bytes. No. 32726. 128 into 1024, Ramcharan. Let me, simple logic, sir. 8 into, what is giga? Giga means 1024 into 1024 into 1024, right? So how can I write like this? How can I represent it? Let me write it here using paintbrush. This is 8 GB, right? 8 GB. Please don't worry about the writing, because in paint I am typing it. I am trying to write it here. So friends, 8 GB means, can I write like this? 8 into, what is giga? Giga is 2 power 30. Giga is 2 power 30. So how many bytes? This is capital B as it is. I am not doing anything here. So 8 GB means how many bytes? Can I write 8 as 2 power 3? 2 power 3 is 8 only, right? I hope you understood what I am doing. 8 can be written as 2 power 3. This 2 power 30 as it is, right? Now this B as it is. B means byte. So how many bytes? If I say I have 8 GB RAM, it means how many bytes, sir? 2 power 33. Bases are equal, powers should be added. 2 power 33 bytes. Okay. Now, for example, I want to convert this into bits. How many bits it is? 8 GB means how many bits? When you have the answer in bytes, you can convert it into bits, right? 2 power 33 into, byte means how many bits, sir? Byte means how many bits? I am trying to write capital B. B means byte. Byte means how many bits? 8 bits. So 1 capital B is equal to 8 small b, right? Then this 8 again can be written as 2 power 33 into 8 can be written as 2 power 3. 8 can be written as 2 power 3. And now capital B has become small b. Now the answer is, bases are equal, powers should be added. Now the answer is 2 power 36 bits. So when I say bits, how many bits it is? 2 power 36. Yes or no? When I say bits, the answer is 2 power 36 bits. And when I say how many bytes, the answer is 2 power 33 bytes. Is the conversion clear, sir? Is the conversion clear? Please let me know in the chat box. Yeah, 2 power 36. Yeah, it's not 2 power 46. Harshita, did you understand what exactly is the process? Harshita has done a small mistake. So Harshita, please let me know your answer, 2 power 46 or 36. Was it clear? Yeah, that's great. So friends, this is how you should know the units of data, because every day we talk about these units. No, how much RAM you have? You say, sir, I have 16 GB RAM, but people don't know what is 16 GB, how much is 16 GB, and what is the meaning of capital B and small b. So we'll try to understand how to represent the data. That is also very, very important, friends. Right now, this is what the point we were discussing, right? So this is, I can also write it as 8 into 1024 into 1024 with, or simply I say 2 power 36, right, bits. Or if I want to write it in the form of bytes, I'll write 2 power 33 bytes. You should be careful Wherever it is capital B, it is byte, and wherever it is a small b, it is bits. People will not clearly or fully write it because there is a notation for it. Capital B means byte, small b means bits. Okay. So how much is 8 GB? How many bytes it is? 2 power 33 bytes. How many bits it is? 2 power 36 bits. Right. Now, if this point is clear, then we can go back to our question like, okay, I understood computer knows a computer can recognize only ones and zeros. Everything should be converted into ones and zeros. Every instruction should be in the form of binary. Then it will be very, very, very difficult for us to give command to the computer. For example, if I say, computer, please multiply 450 into 790, then I should remember three things. What is the binary code of 450? What is the binary code of 790? And what is the binary code of multiplication instruction? Then after that, I want to do a division of two other numbers. Then I should remember what is the binary code for division and what is the binary code of those two inputs. Like that, remembering these many binary codes is not practically possible. That's the reason we can't interact with the computer using its language. So friends, we will end this class with a big question mark. What is that question mark? We cannot interact or instruct computer using its machine language. Yes or no? We cannot. Then how do I interact? How do I interact or instruct computer? This is a big question mark. So is the question clear? We can't interact with the computer using machine language. That is very clear because you just now understood how difficult it is to remember these many binary codes. Then the answer, how do I interact or instruct computer? Then what is the solution? How do I interact or instruct the computer? This is the next question, and we will try to start our next class by answering this question. So before we wind up, till this point, is it clear? Are the points discussed today are clear to everyone? If you have any doubts, please type in the chat box. So let me just summarize what we have discussed. The most important point which we have discussed today is block diagram of a computer. We understood two important things, like there is only one guy in the computer who will work for you. His name is CPU or processor. CPU interacts only with main memory because of that speed issue. CPU will not interact with any other IO devices directly. This is one what we say very fundamental point related to block diagram of a computer. Now coming to how a computer works or how computer understands the instruction. Since it's an electronic device, it wants everything in the form of ones and zeros because it can sense only presence and absence of voltage. Now the problem is, how do I instruct a computer? Because I want to use computer because it's very fast and accurate. I would like to use computers for my day-to-day activity. But I can't give instruction to computer using ones and zeros machine language, the difficulty we have seen just now. So how do I give instructions to computer? How do I use computer more effectively? What is the solution or answer to the question which we have discussed just now? How to give instructions to the computer? No, if there is absence of voltage, how computer will work? Ramcharan, it's not about, it's not exactly same as that fan example wherein you power off your computer, turn on computer, then turn off. No. Once the computer is turned on, computer as a whole is a device, right? Once the computer is turned on, what we will do is, the CPU is a very, very small device. Its size is more or less similar to a hide and seek biscuit which sits inside the computer on the motherboard. That CPU will get signals, that processor will get signals from its control unit in the form of ones and zeros. That collection of ones and zeros together becomes one instruction. For example, let us say 0, 1, 1, 0, 1, 1. Now this instruction contains 2 zeros and 4 ones. So this 0 doesn't mean the computer is turned off, right? This is 0, 1, 0, 1 together becomes one instruction. Maybe let us say it represents addition, like that. So turning on the computer by giving power supply is one aspect. Once the computer is turned on, till you turn off the computer, the CPU will be working continuously. So CPU will get instructions from its control unit in the form of binary codes like this. So 1, 0 or presence of zeros inside the instruction doesn't mean that it is turned off, right? So please try. This is a very valid point. Try to differentiate these two words. Not only Mr. Ram Charan, for everyone I am telling you, computer and CPU are not same. I'm typing in the chat box. CPU is one part of the computer. CPU is one part of the computer. Of course, one very important part of the computer, right? So they are not same, no? Computer is a big device. It has got monitor, keyboard, input, output devices. Everything together is a computer. But inside a computer, the one who actually performs your task, the one who actually executes your job is the CPU. And CPU understands instructions in the form of ones and zeros. Now, for us, it is difficult to remember these many binary instructions. Got it? Now, for example, I'll tell you one more problem. Suppose you bought one i3 processor and you started using it. Forget about, the present scenario. Imagine only machine language is the option. Now, i3 processor has got 50,000 instructions. With lot of difficulty, you have mugged up those 50,000 instructions and you started interacting with the computer, started giving commands to the computer. Now, what happened is after 2 years, you wanted to upgrade your computer. From i3, you bought some i5. Now, will you learn again the new instructions of i5, which is around 1 lakh or 1.5 lakh? It's not practically possible. So, there are two important things. Probably the summary of today's class is computer can only understand machine language. And the another important point is it is very difficult for us to use that machine language. So what is the alternate mechanism? That alternate mechanism we will discuss in tomorrow's class. So what is the question which we have framed today? How to interact with computer using machine language? It is very, very difficult. That is clear. So what is the other method or what is the mechanism to interact with computer? Machine language is not possible. Then what is the other option, right? How do we give instructions to computer apart from machine language? What is the other option which we have got? That is the point. Okay. So is the question clear to everyone? The question which we are going to answer tomorrow. Is the question clear to everyone? Is the question clear? Yeah, fine. So was this session useful? Did you understand anything? Was this class useful? Also give your quick feedback in the chat box. Was this class useful? Right. That's great. Okay, friends. So we will try to meet tomorrow again at the same time. I'll be sharing the link, or maybe your head will be sharing the link. Right. And if possible, this recording also we will try to share. Thank you. Thank you, everyone.